Hi guys! Welcome to my first video of 2017-2018 school year, all about exponent homework. So these are labeled a little bit incorrectly. We call this one a product rule, this one a quotient rule, and this one, power rule, power rule, power rule, 0 and negative. Let's make this look more like a quotient. So, on number 1, we've got a product rule because you've got a base to an exponent times a base to an exponent. Remember that the product and the power rules look very similar, except that the product has one base times another base, whereas the power rule only has one base to an exponent, or multiple bases to an exponent, or multiple bases to an exponent. So, for this one, first we're going to multiply the coefficient, which is 2 times 2. This is hard. 2 times 2, obviously, 4. Then I'm not going to expand it out, but remember that you're not going to multiply the exponents, you're going to add them, because this is like saying you have two m's, and then this is like saying you have another 3, so totally you have 5 m's. So the answer to number 1 is 4m to the 5th. Number 2 is also a product rule, base to an exponent times base to an exponent, but look at this. You have a negative rule in there as well, or a negative exponent as well. So remember, with all negativity, we kick it out, or kick its butt, as Mr. Loyal would say. So this is currently secretly over 1, so you're going to bring it down. And remember that the negative 3 only applies to the m. If it also applied to the 2, then there would be parentheses around it. So 2 times 1, remember there's a secret 1 in front of here. 2 times 1, 2. 4 m's, and then I'm just going to rewrite it, m to the 3 equals, oh no, I've run out of space. Write it over here. I'm going to get better at this, I promise. Now, right here with an m and an m, we have got a quotient rule because we've got a base divided by another base. It's not a power rule because we don't have it all raised to a certain power. So it's a quotient rule where you've got a base divided by a base. So the 2 is going to stay on top, and then we've got 4 m's divided by 3 m's, and when you cross, only 3 can cross out, and you've got 1 left over on the top. Okay, I think I'm going to abandon this color coding now and just use black. Alright, same thing for number 3 and number 4 and number 5 and number 6 and number 7 and number 8. Look at all those product rules, my goodness. But we've got a negative rule, which is going to create a quotient rule, a negative rule, which is going to create a quotient rule, negative, negative, quotient, etc. So this, bring it down, becomes 4 times 2, which gives you 8. And then 3 on the bottom, so 3 r's on the bottom, and then still 2 r's on the top, r squared. Now we've got a quotient rule with base divided by a base, r divided by r. When you cross out, you've got 2 left on top, you've got 2 on top, 3 on the bottom, cross out, there's 1 left on the bottom. So, final answer, 8 divided by r. Next, 4 times 2, 8. 4 ends on top. Negative rule brings it down. Cross, cross, cross. 8. Oops. The 1 is going to be left over on the top because there's 4 on top, 3 on bottom. You get 8 and the next, oh, this is too easy. The only thing to remember is that when there's no exponent, it's a secret 1. So 2 times 4, 8. Oh my gosh, so many 8s going on right now. And then 4 K's and 1 more K. Alright, this one, I'm going to cross that out and write it as y cubed. Cross that out, write it as x. So now you have 2 times 2, which is 4 on the top. Oh, look at this. You've got a y cubed divided by a y cubed. Well, anything divided by itself just cancels, or anything divided by itself is 1, and you don't need to write 4 times 1, because 4 times 1 is just 4. And then you have 3 x's on top, 1 x on the bottom. You're only going to get to cross 1 out, and when you're left, you're going to have 2 x, ooh, 2 x's left on the top of the fraction. Next is only slightly different. It's still a product rule. It's still multiplying the coefficients. 2 times 3, which is 6. And then this time, see how the y and the x, they're both bases, but they're not the same base, so you can't really do anything to it. You could write it as 6y squared times x, or 6x times y squared. I like to go alphabetical, so I'm going to go like that. But you could also say 6y squared x. Last one for right now, which is 4 times a secret coefficient of 1. Which is 4 times 1, which is 4. And then you've got 3 v's and 1 more v with the secret exponent of 1, which would be v to the 4th. And then you've got 2 u's, or u squared, and no u's over here, so you just write u squared. Boom, 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 boom. And that's 1 through 8. Alright, now these are only slightly more difficult, although they look way more difficult. Number 9 is a power rule, because you've got all this stuff with bases, base, exponent, raised to an exponent. So it's going to be like this one, and this one over here. Alright, so this 2 gets applied to the base of 3, it gets applied to the base of x, and also it gets applied to the base of y. So it's just like saying 3 squared times x cubed squared times, that's a 2, times y to the 4th squared. Ugh. And what you see, oh, it doesn't actually, oh, well, shoot. You know from class that when you have a power rule, you multiply the exponents and then apply the power to the coefficient. So 3 squared is 9. X cubed times, squared, is not going to be x to the 9th. It's going to be x to the 6th. Y to the 4th squared is going to be y to the 8th. Oh, I have much to learn. Okay, same thing with this, even though it has a quotient in the insides. I like to go inside out and do the power last, but notice how 2 and 3 don't divide nicely, so we can't do anything with that. A and B and C are not any of them the same bases, so there's nothing actually to simplify first. This is just a straight up power rule going on here. So we have so many bases to apply this 3 to. The 2, the A, the B, and the 3, and the C. So I'm not going to rewrite it like I did this, because that's just a lot of space that I don't have. So 2 cubed, I will write it like that though. And then a squared times 3 becomes a to the 6th. And then b to the secret power of 1 becomes b cubed over 3 cubed c to the 9th. Which we just need to simplify this base and this base. So 2 cubed becomes, I will do this in a little bit different, 2 times 2 times 2. Well, 2 times 2 is 4, and then 4 times 2, 8. That's the number one mistake. People just want to say 6. 2 times 3, 6. No. 2 cubed is saying 2 times 2 times 2. Alright. Anyway. Oh. Eight, a to the 6th, b cubed, divided by 3 times 3 times 3. Well, 3 times 3 is 9, times 3 is 27, c to the 9th. Alrighty. This one, same thing. M and N can't do anything because they're different bases. So the 4 goes to the 2, the 4 goes to the M, and 4 gets applied to the N. So 2 to the 4th, M, 2 times 4, 8, N, secret 1, 1 times 4, 4. Almost done. 2 times itself 4 times is going to be just like this, but we're going to add another 2. 8 times 2, 16. So, 16, M to the 8th, N to the 4th. Another one. X, Y, and A, not the same base, can't do anything. 6 and 7 don't divide nicely. So all we're going to do is apply this 2 to all of the bases inside the parentheses. To the 6, to the X, to the Y, to the 7, and to the A. So 6 squared, or 6 to the power of 2, 36. X squared, squared, X to the 4. Y to the secret power of 1 times 2, y squared, over 7 squared, 49. A to the secret power of 1 times 2 is a squared. Boom, 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 boom. Done. Now to the back side. Almost finished. Okay, so I'm about to run out of time to do this, so I'm going to go a little bit faster. So I might only get also 23 and 24 done, maybe 25, I don't know, hopefully. So any number divided by itself is 1, but we don't really need to write a 1 because remember there's always like a secret 1 involved in everything. So we don't need to write the 1. So then we have 4 n's on the top and 3 n's on the bottom. Well, 3 of them will cross out with up here, but then there's going to be a leftover up here, which is just going to be n. You could write 1 n to the 1, but that's kind of extra. You don't need to do that. Here, nothing to cross the 2 out with. Don't really need the 1, except look, there's 4 n's on top, 4 n's on bottom. All 4 cross out with all 4, and you can do that because they're the same base. So you would only get that because all the m's cross out. But the thing is, you can't leave this blank, so we do actually need the 1 as a placeholder. So just 1/2. Almost finished. Just going to try to do this one, which, negative rule, bring it down. This time, unlike a few that we saw on the front page, or the first page, it's not going to create a quotient rule because the quotient rule is already existing right